Hello and welcome to Mrs. Law's class. In this video, I'm going to show you how to find a specific term of a binomial expansion. Now, if you recall, I'm actually going to scroll back. If we are looking for the first term, notice that the r value is 0, so 3c 0. If we're looking for the second term, notice it's 3c 1. So noticing that this pattern continues, if I'm looking for the third term, we have 3c 2. So this gives us the following general term of the expansion of x plus y to the power of n. So I'm going to say that we're going to look for the t, the term. I'm going to call this k plus 1. This is equal to nck. Because remember, if I'm looking for the first term, then this k value actually has to be 0. If I'm looking for the third term, notice that the k value would then have to be 2. So then this becomes x to the power of n minus k, following what we did before with the binomial theorem, and then y to the power of k. So put a box around this to show you that this is a very useful formula if I want to find any term. So let's take a look at an example. So use the general term of the binomial theorem to determine the 8th term of 2a minus 3 all to the power of 9. All right, so this is our general term. We need to know what n is. We need to know what k is, x, and y. All right, so n is our exponent. So that is 9. K, because we're looking for the 8th term, k is actually 7. Remember, it's 1 less. X is 2a, and our y value is negative 3. So we can write it out like this. So if I'm looking for the 8th term, I'm looking for t8. This is the same as t7 plus 1. So now I know that my k value is actually 7. So then we have 9c7, 2a to the power of 9 minus 7, and then times negative 3 to the power of 7. So using my calculator to calculate this, 9c7 is 36. And then we have 2a squared. So it's going to be 4a squared. And then negative 3 to the 7, I'll need to calculate for that for sure. That's negative 2,187. All right, so multiplying all the numbers together, I'm going to get negative 314,928, and then a to the power of 2. So this is how you use the general term to be able to find any term in the binomial expansion. All right, let's take a look at a different type of example. All right, so in this question, I'm asking you, so in this expansion, x cubed minus 2 divided by x squared all to the power of 10, I want you to find the term that contains x to the 15th. All right, so how do we do that? Well, we don't know which term that is. So I'm going to say that this is 10, because that's our exponent, ck, and then we have x cubed, and we know this would be 10 minus k, and then we have negative 2 over x squared to the power of k. And then somewhere along the way, we know that this has to equal x to the 15. Now, I'm not really concerned about what the numbers are, like we have a negative 2 here, okay? But what we are concerned about is the power of x's. So here, we need to look at this part here, and we also need to look at this here, which also has a power of k. So here we have x to the power of 30 minus 3k. And this x squared is in the denominator, so I'm going to write it in the denominator here. And then it's to the power of k, so this will be x to the power of 2k and this equals x to the 15. So using my exponent rules on the left side, I'm going to get x to the power of 30 minus 5k, because we're going to subtract the exponents because we're dividing, equals x to the 15. So now our bases are the same, so our exponents have to be the same. So 30 minus 5k equals 15. Negative 5k equals negative 15. So k is equal to 3. All right, so knowing that k equals 3, so according to my general term, this would be 3 plus 1. That means I am now knowing that I'm looking for the fourth term. So it does say write and simplify the term containing x to the 15th. I'm not just asking what term it is. I'm not just looking and saying, hey, it's the fourth term. We actually also want to find what that term is. So we're going to now expand. So this was exponent of 10. So this will be 10c3. And this will be x cubed to the power of 7, so it's 10 minus 3, and then negative 2 over x squared, all to the power of 3. So we get to practice using the general term again. So 10c3 is 120, typing that on the calculator, x to the power of 21, and then we have negative 2 cubed, which is negative 8, and then x to the power of 6. So simplifying this, we get 120 times negative 8, which is negative 960. X to the 21 divided by x to the 6 is x to the 15, which is what we wanted. We wanted to find the term that has x to the 15. And then that's how we do this, using a bit of algebra and then using the general term.